Security is kind of like, it's like car insurance. You have to have it. You don't want to spend a whole lot of time thinking about it, but when something happens, you really wish you would have thought about it more. And so I actually think we're in some really compelling times right now with the onset of 5G and IoT and smart everything, where we're probably not talking enough about security. So we heard earlier, I think we saw some John Lennon song lyrics about, imagine all the people. I wanted to open up with this picture. And so I gave an interview recently where I was asked to comment on the world's first flying car that was debuted at an auto show in Geneva. And I thought the interview was about security, and it was more about, I was supposed to comment on, how cool from a technology perspective it is that we can talk about flying cars in this day and age. And my comment was, in general, it's a really cool concept, but have they thought about security? Okay, and maybe they have. I don't know anything about this manufacturer, but it really stops you in your tracks and makes you think. So when you think about autonomous vehicles, which is all the rage right now, there's actually vehicles on the road. Some of you may have them, luxury vehicles that can stay between the lines and help you navigate home, kind of in a glorified cruise control. We could park the car for you. So let's rewind a little bit to some attacks that you may have seen on your home computer. Okay, everybody's been hit with malware on your computer or your phone. Most of them aren't going to cause any kind of lasting damage. They might slow down the performance of your computer. But in many cases, ransom attacks have been on the upswing. And this is a situation where somebody might say, I'm holding your computer hostage unless you send me, $10,000 in Bitcoin, okay? Now let's move back to this again, all right? A ransom attack, when you're in your autonomous vehicle, or even worse, you're in your self-flying car, okay? Not something I want to think too much about, because now it's not just something that's going to hit your checkbook, but it's something that could potentially be life-threatening to not only you, but society at large, right? Now, I don't want to be the fearmonger up here, but I mean, the reality is when you think about IoT, somebody mentioned the thermometer at the casino. I don't know if everyone knows that story. The thermometer at the casino was a thermometer in a fish tank in Las Vegas that somebody hacked to get access to the casino's entire database, okay? If they can hack a thermometer, believe it or not, they can hack an autonomous vehicle that is really nothing else than a very large IoT device that has the same vulnerabilities and security concerns, okay? So that kind of sets up my talk today. And I want to start out with just a couple slides on the landscape, excuse me, for security today. And so what we do at Radware every year is we put together a research report that's based on a survey we take across the industry. And it's also based on surveying our own people who are really experts in the field of cybersecurity. Some of them used to be, excuse me, hackers themselves, and now they're kind of, white hat hackers. And we try to make it as global as possible, and we try to look at the industry across multiple verticals. And so what we've seen is that from that, we've seen a couple takeaways. One of them is that nearly half of the enterprises out there have suffered a data breach. And it's important because let's look if you're a service provider. If you're a service provider, not only have you made yourself vulnerable from a PR perspective, but you also left yourself at risk for lawsuits. And so, and it doesn't really matter if you're a large enterprise or a large service provider who's protecting enterprises. You could be an individual consumer, or you could be a small business. It doesn't really matter, because if a hacker can get access to your data, for monetary gain, then they will do it. In fact, we've seen that 60% of small businesses in the U.S. have been hacked in the last 12 months. We've also seen that there's an emphasis on privacy. With GDPR looming in the European Union, this puts a whole new set of concerns on how we're going to protect individuals' data, or how we're going to share individuals' data. Again, that goes back to the transportation domain when we think about sharing data for autonomous vehicles. So protection is a big deal, and most enterprises understand this. Not all, but most understand this, and that there needs to be an increased investment in cybersecurity solutions. So the other thing we're seeing is that more than half of the 3 biggest attack types have lasted an hour or less. So we're starting to see increase from 2014 in the duration of attacks that tend to be continuous, and the amount of attacks. So there's an increase in the complexity, and there's an increase in the quantity and the duration of attacks. And some of these are just attacks that can debilitate a network. So you really just see a performance degradation. And some of them are attacks that can cause a complete outage. But the key takeaway from this slide that I want to leave with you is that there's been a marked increase in automated attacks. So these are attacks done by other computers that are malicious, and not necessarily by a human behind that. And so this is where we give rise to the era of botnets. And so is your data in good hands? And so there are legitimate botnets. And in fact, there's a lot of traffic that traverse organizations' infrastructure that come from or originate from bots. Up to 75% of total traffic can originate from bots. And a lot of this traffic could be non-malicious in nature. You could use bots for things like gathering real-time information, for news, for sports, for weather. You could use bots for things like queries on the web. You could use bots for traversing auction sites or shopping sites to try to see where the best deals are. And so a lot of these things are not bad in nature, but bots, up to 30% of the traffic can be from taking those bots that could be used for good and in fact use them for evil. And so there's things like DDoS attacks, web scraping to steal information, intellectual property from others' websites, the ability to manipulate pricing, ability to grab inventory. So these are all things that we need to be cognizant of. Excuse me one second. All right, so what are some examples of modern day bots? Well, IoT is really the birthplace for new types of bots and new types of malware attacks. Some of these are very rudimentary, but we're beyond the days of, there's a human hacker that tries to attack a port on a server and just blast it with traffic so that you overflow a buffer and render the equipment to a state where it's not working anymore. We've seen things like Mirai. Most of you have probably read about in the news, where Mirai took down the DIN server, the DNS server, and could take a large portion of a national network down. We've seen hundreds of thousands of bots acting in unison to do a coordinated attack. Here we've seen bots that have originated for kind of vigilante reasons to protect against IoT attacks, and at least that's what they state their main intent was. So things like Hajime and Brickerbot. And so what they do is they'll go into a device that they think might be not acting appropriately, and they, in the case of Brickerbot, and this is a threat that our researchers at Radware found, it can basically turn your computer into a brick by rendering it completely obsolete. And so some people have used that not as a vigilante mechanism, but as another malicious mechanism. And then we've seen other versions of Mirai manifest over the last year. Satori is one that, again, Radware researchers found, where we've seen 280,000 different IP addresses being used over a period of 12 hours. Just an unbelievable amount of coordination. Gen X is something that impacts video gamers. So the video game Grand Theft Auto, it has the ability to infect IoT devices for users that are playing that game. And so these are very, very lethal types of IoT-based botnets that we need to be concerned about. And so we had a lot of people leave the room since last session, but we still have a fair number here to take just a quick survey. So IoT, I don't know who's in here representing service providers, but whether you're a service provider or not, is it their responsibility to protect the network against all these IoT devices? Quick show of hands. Who thinks it is? Okay, is it the IoT manufacturer? Is it the thermometer guy or the refrigerator manufacturer who's connected to the network? Should they be the ones to do it? Quick raise of hands. Is it the consumer who's chose to buy, that new fancy piece of technology, but didn't really care whether it was protected or not? Is it the enterprise? When you bring your own device to work, are they responsible for it? The answer is, it's not clear. What is clear is that we're going to have something in the order of 40 to 50 billion IoT devices within probably the next 6 or 7 years. And that's based on research reports from analysts. Already today we have, I think the tipping point has happened where there's more IoT connected devices in the world than there are people. So with that, we've seen 1 in 6 organizations report that they've seen an IoT botnet attack through private survey. If you were to ask service providers, they probably won't all admit it. And I would guess that the number is much larger than that. And so there's a huge concern for management of these organizations to figure out what to do about it. When you look at IoT in general, are we worried about the high rate of false alarms, more headcount to manage those devices, DDoS attacks coming from those devices, excuse me, or in general, just more difficulty in security management when integrating those devices into the network. And by far, it's the latter at 47%. So it is a perfect storm, so to speak, for the service provider. What can a service provider do in this new era to protect not only their infrastructure, but the enterprises that they serve from a managed security services perspective, or from just a bandwidth or high value added service perspective? What can they do in these various scenarios to protect against the IoT security nightmare? And so one issue that we all have to balance, and several of the folks before me have talked about, budget, right? So if you're the large tier 1 operating in North America, or one of the large tier 1s, I should say, or other parts of the world, and you already have a security operations staff of, let's say, 50 people, right? But the traffic on your network is going up, 5-fold, 10-fold, really almost at an exponential rate. Can you hire enough people to manually look at all the security events that are coming into your network on a daily basis and troubleshoot that? The first problem is just costs. The second problem is expertise, finding those people who can do that. And the third problem is just really not going to scale, and it's not going to be effective, and you're probably going to have a lot more errors due to manual troubleshooting and attempts to mitigate than if you had automation. So there's a clear need for automation. And so the paradox is that you have all these different security products that you think are protecting your network: firewalls, IPS, IDS equipment, DDoS appliances, whether they're virtual appliances or physical appliances. But what do you do with all the data? Okay, and so there is a pretty obvious need for automation, and there's a need for automation that not only does some action without human intervention, but does it in a way where it can learn and eventually have some sort of cognitive human-like behavior while it's doing it. So we need the machine power, but we also need some sort of AI built into it. And AI tends to be an overloaded term, right? If you look at security on this graph, what we're trying to say here is that you can code up security algorithms to do things that are fairly easy, like look at protocols that are known, that have known message flows. For example, TCP with SYNs and SYNACs and all those things. And you could look for bursts, and you could look at ratios of parameters, and you could look at, you know, where there might be an anomaly. And that's fairly easy to do. But as you go across the spectrum here, what's not easy to do is figure out in a network where machines are being used to attack, and you have all this data now coming from all these devices which are supposed to be helping you. How do you correlate all that? And then how do you take some sort of policy mitigation decision based on all that? The data needs to be good, and there's a lot of it. You need to figure out what's real data and what's false data. And so the complexity goes up. And so TCP is not TCP, coded algorithms is what we've done for a long time. We're moving to machine learning, which still has an emphasis on algorithms and computational math models to solve problems based on machines doing the analysis and the modeling. And what we need to really get to is a deep learning neural network, okay, which is more like your brain that can do all this sampling and do the correlation. And that's the part where today, I think in cybersecurity, we're not quite there yet, and more research needs to be done here. But I do think it's coming soon, and I do think it's a killer app for security to figure out how to battle against all the automated attacks. And so we need a lot of good data to do deep learning, but we also need to figure out the best way to use it. And so to detect and mitigate quickly right now is probably not the best way to use neural networks, deep learning, but it probably is best suited for machine learning, which is a little bit different because we're still able to use models. So with this is DARPA. DARPA held an event where they had autonomous machines that were unmanned try to play the capture the flag game. And so they were tasked with trying to have automated systems discover and exploit vulnerabilities while still protecting their own equipment. And there was zero human intervention in this. And it was really interesting to see machines go against machines 24/7 and try to battle this out. And we also seen a similar thing at 2017 DEF CON. We've seen that bots can now be the next big thing with malware. They can generate malware. So Elon Musk from Tesla had an open artificial intelligence framework that a security company was able to utilize to create new malware types from. So it's AI isn't always used in a beneficial manner. We need to be careful about how we're approaching it. Here's some ways that hackers can use machine learning in a malicious way. They could, again, new malware, which I just talked about in the examples at DARPA, using hive nets and swarm bots to figure out self-learning ways to attack a network again at high volume, spear phishing at scale using natural language processing algorithms to do that by looking at genuine, valid emails and doing training and learning on it, and then raising the noise floor. So when you're when you have all this data traversing the network, video, pictures, there's a way to figure out how to turn that into false positives. So instead of looking at a picture of me, you might alter it just a little bit, and the AI algorithm might be fooled into thinking it's a picture of somebody else. So these are all things that are the good and the bad with artificial intelligence. But in general, what we need to do is look at an automation life cycle that can use machine learning in a multidimensional space to solve the toughest problems. We need to be able to detect real-time anomalies without having to just use existing signatures that we know about. So we need to detect them in real time, and then program the network with some sort of automated policy that can take action on it. And so the real-time investigation and mitigation is what's key to all this. And so what we do at Radware is we kind of use the data plane is the products, the physical or virtual appliances that do the actual work of detection and mitigation, whether it's moving flows around to scrub traffic or whatnot. The control plane is how we take inputs from the network from multiple directions and make some sort of network level centralized decision. So we're not just looking at bits and bytes, but we're able to use other types of information feed. And then the big data and deep learning, we have this today, and this is where we're using our global network of scrubbing centers to profile where attacks are taking place, not so we could do fast mitigation, but that we can use that as a intelligence feed going forward, and feed it into the rest of the system. And by doing that, machine learning combined with our intelligence feed at a high level with our experts, we're able to take attacks that could take up to a half hour, based on attacks from machines, and we're able to mitigate them in seconds now. And so, and some of our product releases as of late have built in new auto-detect and mitigation algorithms to identify some of the latest bot storms that are out there. We use the network as a sensor to collect telemetry. The richer set of data feeds that we have, the more that we can do with it. Our products are distributed in other products in the ecosystem. It's integrated in Cisco Firepower. We're integrated in Checkpoint. We're interoperable with other detection algorithms on the market as well. And this is where we're able to get our neural analytics layer from real-time analytics feeds all the way across the globe. We have a 3.5 terabit scrubbing center capacity built up with Radware equipment that's able to capture and analyze all the attacks happening around the world. And so, having a comprehensive security solution really starts from inside your network outwards. And this picture just kind of shows how we're able to deal with, peeling the onion back, so to speak, and protect at multiple levels and multiple layers to deal with the new era of complexity of attacks from IoT devices. And that's it. I went a little bit overboard. So I think I probably don't have time for questions, but I'm here the rest of the day and tomorrow, so feel free to stop me and ask if you have anything. I appreciate your time.